Today's video is on Unit 6, Lessons 8 and 9. Lesson 8 is a review of factoring by completing the square. So please make sure you listen carefully because I'm going to review how to do that within the first question. So the first question says they graphed the function y equals x squared, which is shown right here on your graph. Then they want you to graph this guy so you can see what happened to x squared. Did you move left? Did you move right? Did you move up? Did you move down? Well, in order to do that, you need to factor this quadratic into this form. This is called the vertex form. To do that, you have to use completing the square. So I'm going to walk through how to do completing the square with this example. So I'm going to rewrite the quadratic. Step number 1 in completing the square, and everybody teaches it differently, but this is how I teach it, is to move the number that doesn't have an x or a variable with it over to the other side, just temporarily. So I'm going to move this plus 18 over to the other side to be minus 18. Whoops. Now I'm going to leave, it's called completing the square because we are going to turn this quadratic into a perfect square trinomial. To do that, you have to follow these steps. First of all, make sure there's a 1 in front of your x squared. If there isn't, you're going to have to take a GCF out, which means you're just going to have to divide by whatever number that is. We don't have to worry about that because there is a 1. So step number 1, and I like to draw this little square to help me remember the steps. You're going to take half of this number. So half of -8 is -4. Then you're going to square it. So you're going to do -4 squared. It's always going to be a positive number. It's positive 16. That number then goes in that third spot where the 18 was. But to keep this equal, whatever you do to one side, you have to do to the other. So I have to add 16 to this side as well. Now you just turned this into a perfect square trinomial. What that means is when you factor this using your 1am method, you're going to get the same factor twice. So first let's combine this side. 16 and -18 is -2. And when you factor this using 1am, the factors of 16 that will give you -8 is -4 and -4. Notice you got the same exact thing, which means you can rewrite this as x minus 4 times itself, which is squared. Look, it looks very similar to what I'm supposed to get. Now bring this 2 back over to this side and then replace this with the y again. So this is my vertex form. Now what that tells me, if you think back to Algebra 1, whenever there's a number outside of the parentheses, this tells you how far that you go up or down. When there's a number inside, it tells you how far you go left or right. So if the number is outside of the parentheses and it's positive, you're moving up. So I'm going to be going up to, I'm going to take the vertex, the original vertex. I'm going to go up to, and then this number, you would think you're moving left, right, because it's a negative, but you're actually going to do the opposite. You're going to be moving right 4. So I'm going to move right 4, 1, 2, 3, 4, and up 2. Here's my new vertex, and every point is going to move that same distance. So 1, 2, 3, 4, up 1, 2. If you just plot a couple of them, 1, 2, 3, 4, 1, 2, and it'll look like this. So you have to remember what the numbers do transformationally to a graph. So keep that in mind. Now, it says, describe how it moved. We already did that, so you can say up to right 4. And then, now that we turned it into vertex form. Vertex form is what we used completing the square for. And so once you turn it into vertex form, you can identify the vertex. Remember, the vertex is the turning point. Okay? It is where, actually they said that in the next sentence. It is where it turns around. It's where it turns from going down to going up or vice versa. So the vertex is going to always be this number and this number. This number is your x coordinate. This number is your y coordinate. But you have to change the sign of the number that's inside the parentheses. So the turning point would be 4, 2. He's the only one that his sign gets changed. And that's it for that question. So we're going to practice this a little bit more with completing the square. These two are a little trickier because if you notice, there isn't a 1 in front of the x squared. There's other numbers. So we're going to have to GCF that number out. But the first step is always the same. So you're going to add the 2 over to the other side temporarily. You're going to just move them over there for a little bit. So this is going to be 2 equals 3x squared plus 12x. And then I'm going to leave a space for that third number. But before I can do this, there has to be a 1 in front of the x squared. So what I need to do is divide everything on the right by 3 because I don't want that 3 there. So if I factor out the 3, I have x squared plus 4x. Now I'm going to complete the square inside this parentheses. So if you take half of 4, that's positive 2. If you square it, that's positive 4. So I'm going to add 4 to both sides, but be careful. You're really not adding 4 to both sides. You're actually adding 12 because there's actually 3 4s. So when you add your number to the other side, you have to add 3 4s, which is 12. So this 12 came from 3 times 4. Because of that 3 I pulled out. So I did not add on just 4. I added 3 4s. So now 12 plus 2 is 14. This is a perfect square. The 3 stays there. This is a perfect square trinomial, otherwise known as, if you use the 1 AM method, it's x plus 2 times x plus 2. Well, I can rewrite that as x plus 2 squared. And now I'm just going to move the 14 back over here. So I'm going to subtract the 14 over to the end, and now it is in vertex form. So your equation is y equals 3 parentheses x plus 2 squared minus 14. Now you might be wondering what this 3 does to the graph. So the vertex is at -2, -14. The 3, if there's a number out in front, he just makes it either skinnier or fatter, wider. So it would have taken your original graph, the x squared graph, and either like made it a wider U or a more narrow U. So that's all the number out in front does. So the vertex is still this number, but the opposite sign. And then this number stays the same. So it's -2, -14. That's where the vertex is. All right, letter B. Again, move the 1 over. So it's going to be -1 equals. Before I write this down, I notice I need a 1x squared. So I'm going to factor out the 2. So that's 2x squared plus 3x. And I'm going to leave my blank because I'm going to complete the square. Well, this is kind of a gross number. Half of 3 is 1.5. I'm going to leave it as a fraction. So it's 3 halves. When you square 3 halves, you just square the top, square the bottom. That's 9/4. Gross. I'm adding 9/4 here. Now, remember, I'm not technically adding 1 9/4. I'm adding 2 9/4. So 9/4 times 2 is 18/4. So I have to add 18/4 to this side. We should reduce 18/4. That's really 9 halves. And if I subtract 1, 1 is otherwise known as 2 over 2. So 9 minus 2 is 7 halves equals. Now I'm going to show you a little trick. This will always factor to be whatever half of this middle term was. So it'll be x plus 3 halves squared. You will notice if you look back at the ones we've done, half of 4 was 2, and it factored to x plus 2 squared. It will always be that way. So now I just have to move the 7 halves over. So this is y equals 2 parentheses x plus 3 halves squared minus 7 halves. So the turning point, remember this number does not affect your turning point. It either makes the graph skinnier or wider. The turning point will be at -3 halves, comma, -7 halves. Okay, last questions. This one, they just want you to find the turning point, and guess what? There's a formula for it. So you technically, unless they tell you to use vertex form, you don't have to. You can use this formula. You have seen this. It is -b over 2a. Someone go grab that. Now, real quick, the a is in front of the x squared, and the b is in front of the x. So you just have to know what those numbers are. So if you look at this one, the b is -12, and the a is 2. What? hold on. Okay, so this is going to be a negative 12 over 2 times 2. Well, a negative is a positive. 12 divided by 4 is 3. So the x coordinate is at 3. And then you're going to plug 3 back in to find the y coordinate. That turns out to be negative 11. So your turning point is at 3, negative 11. Okay, so for example B, we just have to find the vertex. We're going to use this formula. B in this case is 5. A is negative 1/4. So if I do negative 5 over 2 times A, which is negative 1/4. So that's negative 5 over negative 2/4, which is 1/2. A negative over a negative turns into a positive. 5 divided by 1/2. You can either use your calculator or you can know that that means 5 times 2, which is 10. So the x coordinate is 10. You're going to then plug in 10. So you're going to replace all of your x's with 10. You can use the calculator to find your y, or you could graph it and look at the y coordinate at 10. It is 5. So the turning point is at 10, 5. And that is it for lesson 8. Moving on to lesson 9. Lesson 9 should be a total review because all it is taking quadratics and turning them into real-life situations, and you can use your calculator. So this first question talks about some object being fired upwards. So we don't know if it's actually starting on the ground, or maybe it's starting at the top of a building or on a ladder. You don't really know until you answer this first question. It has a velocity of 112 feet per second. So that's the rate. It is going up at 112 feet per second. So that's 112 t. Its height in feet above the ground is given by this equation. So height, t is time, h is height. So at what height was the object fired? Well, when it is first fired, the time would be 0. So you're trying to find the height when the time is 0. So you're just plugging in 0 for t. This should be a pretty easy one to do in your head because 0 times anything is 0. So the height at the time of firing, which is time 0, is 0 feet. So that means it did start on the ground. Now it says sketch a general curve. Well, you better not have negatives because you can't go backwards in time, and you can't, well, I guess you technically could go underground, but we're going to assume our object just lands on the ground. So you can use your calculator. It will look something like this. And in a second, we're going to find some important points. The 3 important points are your starting and ending time and the highest point you'll get to. So letter C says, algebraically find the time that the rocket reaches its greatest height. So you want to find, this is also known, the greatest height is the maximum, which is also known as the turning point, which you learned in the last lesson, how to find the turning point. It's negative b over 2a. So remember, if there is no b or c, it's 0. So in this particular equation, I'll rewrite it right here, there actually is no c, but I don't care about c, so I can write a plus 0 if I want to, but I don't need c for this equation. So b is 112, a is negative 16. So if I plug that in, that's negative 112 over 2 times negative 16. You're obviously going to use your calculator. That turns out to be 3.5. Now we need the height though. Remember x, so this is at 3.5. Remember, this is your time. This is your height. So all you have to do from here is plug in 3.5 for t, for time. So you're going to do negative 16 times 3.5 squared. Use your calculator. Plus 110 times 3.5. It turns out to be, I believe, 196. So that means this height, the maximum it will get is 196. So the turning point is at 3.5, 196. Now it says, part D, algebraically determine this point right here, the time in which it will hit the ground. When will the height be 0 again? You know, in a quadratic, it always, usually, I shouldn't say always, most of the time, it'll cross twice. So you're going to have 2 times when it hits 0. So that means you're going to factor this. So you want to know, when will my height equal 0? So this is not a trinomial because there aren't three terms. So you're going to factor out a GCF. If I pull out a negative 16t, I am left with t minus 7. And then you're going to t-chart because it's equal to 0. You're going to get t equals 0, which we already know. We already know that it started at 0. And then my other t will be at 7. So that means this point right here is 7. So it takes 7, what are we in? Seconds? Minutes? It takes 7 seconds to hit the ground. All right, the last question, it strictly says use your calculator. So you're just going to type this into your calculator and sketch a graph of it. You're talking about a skateboard half-pipe ramp. It has the shape of a parabola. If you type it in, you will notice the highest it goes is 7. It curves downwards, and it's a pretty wide U. Up to this point, it's at 20, 7, and the vertex or turning point is at 10, 1. So that means this point is 10. It goes up to 20. The highest y is 7. The lowest y is 1. And that's all you had to do. Oh, it did say label the height and the endpoints and its minimum point. So I did all of that. And that's it for lesson 9.